Welcome to the Explainer, where we break down complex AWS topics to get you ready for your certification. Today, we're jumping into a really powerful, but let's be honest, often misunderstood layer of security in your VPC, Network ACLs, or as you'll always hear them called, NACLs.
Okay, let's kick things off with a classic scenario. This one trips up a ton of engineers, even seasoned ones. You do everything right, you lock down your inbound rules for your web server, but then suddenly your instance can't even download a simple software update. It makes no sense, right? Well, by the end of this, you'll know exactly why this happens and, more importantly, how to fix it.
So to solve this mystery, we first have to understand that your VPC actually has two totally distinct layers of firewall protection. You've got your security groups and you've got your network ACLs. They both filter traffic, yeah, but they do it in completely different ways. And knowing that difference, well, that's absolutely key for the exam.
Here's a really simple way to picture it. A security group? That's like a personal bodyguard for your EC2 instance. It's attached right to it, follows it everywhere it goes. But a network ACL, that's more like the main security checkpoint at the front door of the entire building. In our case, the whole subnet. It checks everybody and everything trying to get in and out of that entire zone.
Okay, this slide right here, this is where things get really interesting. You can see the differences laid out side by side. Security groups are at the instance level, only have allow rules, and here it is, they're stateful. Now look at NACLs, subnet level, they can do allow and deny, and this is the most critical part, they are stateless. That one word right there, stateless, that is the absolute key to solving our little mystery.
So let's really dig into that one. Because seriously, if there's one single concept you need to master about NACLs for your AWS certification, it's this one, the difference between stateful and stateless. A stateful firewall, like your security group, it's got a memory. It keeps track of conversations that are happening. So if you let a request come in on port 443, the security group goes, okay, I see ya, and it automatically allows the server's response to go back out. You don't need to create a whole separate outbound rule just for that response. It just works. Now, a stateless firewall, like an ACL, it's the complete opposite. It's got zero memory, total amnesia. It treats every single little packet, inbound or outbound, like it's the first time it's ever seen it. This means for a simple back-and-forth conversation to happen, you need one rule to let the request in and a totally separate rule to let the response out.
All right, so let's put the pieces together. We know NACLs are stateless. We know they need rules for traffic going in both directions. So, how does that explain why our instance suddenly can't get out to the internet?
Okay, let's follow the journey of a single packet. Your EC2 instance wants to grab a software update, so it shoots a request out to the internet. Now, that request leaves from a random temporary port. It's called an ephemeral port. Just think of it like a temporary return address. The server out on the internet gets the request and sends its response right back to that exact high-numbered port.
And boom, there's our problem. The response packet comes flying back to your subnet, and the stateless NACL stops it at the door. It checks its list of inbound rules, but your rules only say allow ports 80 and 443. The NACL sees this packet trying to get to, say, port 52123, doesn't see a rule for it, and just drops it, blocked. It has absolutely no idea this packet is part of a conversation your instance started just a second ago. So how do we fix this? Well, the solution is actually pretty straightforward. To let those outbound connections work, you have to add another inbound rule to your NACL. This rule needs to allow the return traffic, which means allowing traffic on what's called the ephemeral port range, typically from port 1024 all the way up to 65,535. That opens the door for the responses to get back in.
Okay, so we've cracked the case. Now that we get the why, let's dig a little deeper into how these NACL rules actually work. Getting the logic down is another must-know for test day.
So here's how it works. AWS reads your NACL rules in order, based on the rule number, starting from the lowest number and going up. The second a packet matches a rule, that rule gets applied, and that's it. The evaluation stops, dead in its tracks. And you have to remember, at the very, very end of your list, there's a hidden rule, that little asterisk, and it's an invisible deny all for any traffic that didn't match one of the rules you wrote.
You know, here's a great little pro tip from the experts over at Z-Zone. When you're making your rules, don't number them 1, 2, 3. Use something like 100, 150, 200. Why? Because it leaves you these nice big gaps, so if you need to squeeze a new rule in between them later, you can do it without having to renumber your entire list. It's a lifesaver.
All right, let's wrap this up with some key best practices. And you're going to want to pay close attention here because these points come up all the time in exam scenarios. This is what you really need to know. Okay, if you remember one thing for your exam, make it this.
For traffic to get to your instance, it has to get a green light from both the NAC and the security group. Think of it this way. NACs are your broad first line of defense at the subnet border. They're perfect for a big, explicit deny rule, like blocking a bad IP address. Security groups, on the other hand, are for the detailed stateful control right up against the instance itself.
And one last thing, keep the default service limits in mind. You get 20 inbound and 20 outbound rules per NACL. Now, you can request an increase, but that limit is there for a reason. It really forces you to be efficient and think strategically about your rules. It encourages you to use NACLs for those broad strokes we were talking about.
So what's the big takeaway here? NACLs are your powerful but very, very literal-minded gatekeepers for your subnets. They don't replace security groups, they work with them to create defense in depth. And understanding their stateless nature isn't just a trick to pass an exam, it's fundamental to building a network that's both secure and works the way you expect it to. So the real question is, how will you use them now to build a more secure network?